So this session is going to be about Azure Machine Learning Services. It's a continuation from our meeting on January 12th. These new features were announced at Microsoft Ignite in September 2016. In Azure Learning Workbench is a cross-platform client for data wrangling and experiment management. The AML experimentation service helps increase the rate of experimentation with data modeling. And then there's a model management service which hosts, versions, and monitors machine learning models. As of January 2018, everything's still in preview, and I've got a link here to that. A lot of this is going to be heavily focused on Python. Its current release is 3.6.4. It was created by Guido van Rossum and was released in 1991. It is named after Monty Python. He was a big Monty Python fan, and it is open source, general purpose programming language. There's a large base library that accompanies Python, used for creating crude desktop, web applications, or scientific applications. Another application is called PIP, which is the Python Package Index, and it's the official third-party repository for Python libraries. One thing you can see when working with it is Python wheels, which are really just zip format archives that extend the base library. These replace the older archives, which were called A. This is similar to NuGet packages or DLLs, for familiarity with other languages. So what we'll be covering today is the Azure Machine Learning Workbench.
Hey, before you get too far into that, you're coming through pretty muffled on our end.
Okay. How about now?
Yeah, that sounds better. Keep talking for a bit.
Okay.
Yeah, that was perfect.
Okay, sounds good. So then we'll go over logging in with the Azure command line interface. We'll set the account and create a resource group. Then we'll look at Azure Machine Learning Services and create an experimentation service, create a model management resource, and set up our environment to compute both locally and in a cluster. Then we'll go over creating a model and building out the workspace, submitting an experiment, viewing the run history, and promote and download the model. Next, we'll register that model, create a manifest, a Docker image, and then create a web service within the Azure Machine Learning Model Management. Then we'll review the local deployment using Docker, the images and containers that get built, as well as inspecting the Docker image and being able to consume it. Then to wrap up, we'll go over the model data collector and the storage account and see how we can view all that data. These were just some links that I had come across that were helpful along the way. So some of the lessons and troubleshooting that I've learned is a lot of Azure resources require you to have lowercase names. There's a experimental feature in Docker that needs to be disabled and then restarted. The Azure Machine Learning Workbench Python folder needs to be added to your system environment variables. And then there's also helpful things in Visual Studio Code for Docker, Python, and tools for AI. Also, I did a lot of the dash help in a lot to get reference to these different commands.
In reference to the
comment about lowercase name for Azure. Is it, or what was your experience? Does it make certain things run locally with case or uppercase names, or when you try to deploy this to Azure, that's when you discover that it failed?
Yes, that it needs to be in the container service, that it needs to be lowercase.
Okay, thank you.
So we've got a link here for installing the machine learning workbench. And there's a window installer that we can get here. And I have it opened up. And this is what it looks like from our meeting last time. And we can open up a command line window and go out to the Python folder in our local AML workbench. And then we need to make sure that that path is added to our environment so that whenever we're working with our Azure resources, that it knows where Python is living. A few initial steps need to be done in order to register our libraries and such with Azure. So there's some AZ provider registry and then showing the status of those. So that's kind of all the upfront stuff on the machine learning services. Are there any questions before we get into actually creating one? And okay. So the first thing we want to do is we'll open up a command line, and we want to log into Azure. And so this will take a moment, and so we can go out to this website. And it will ask us for that code. So we will copy that code and paste it in. And let me minimize this a bit so that we can verify that it does connect. And we'll go ahead and continue. And it wants me to sign into my Azure account. So I'll go ahead and do that. And now it says that we've signed in, and we should get a message here in the console saying that it's ready. And there's a couple points in this presentation that may be a little slow because we're waiting on things to get created and such. But it looks like that did get created. So now we will switch back over to here and see that I'm running a Visual Studio Premium with MSDN with my Hotmail account. Another way to see this information is we can say AZ account show, and that will also retrieve that same information. Another way to see all of our accounts that are listed is by using the AZ list account and see it in a output to a table. So this is all the ones that are currently enabled that I have access to. So let's go ahead.
So in this terminology, an account is equivalent to a subscription?
Yes, okay. Yes. So now we need to set that account to our subscription ID. We'll copy this and then paste that in. And so we'll get a message come back. Oh, I'm sorry, I forgot the -S flag to say that we're setting the subscription ID. There we go. So now we're connected to Azure with our Azure command line interface. So now let's create a Azure ML resource group that will store everything that we're going to work with today. Okay, so that's been created and it says it succeeded. So So let's go over to Azure and see our resource group. And we should have a new one here for Azure ML. Okay. So the next thing is there's multiple services available with Azure Machine Learning Services. We'll go out here to their website. And they have a workbench, experimentation service, model management, Visual Studio Code tools for AI, AI toolkit for Azure IoT, and MML Spark. So a whole lot of new things are available. The workbench is like we had seen last time, a desktop application and the command line interface to prepare data and steps and models. Our experimentation service is a prototype and controls project. The model management is where we deploy and manage models and consume them via web services. Visual Studio Code tools for AI is extensions inside of Visual Studio Code. The AI toolkit for Azure IoT Edge deploys and run models on IoT devices. So these could be Arduinos or Raspberry Pis. The MML Spark is Microsoft Machine Learning for Apache Spark. And this is what the Docker container that we're going to work with today is running behind the scenes.
Okay.
So first, we need to create a new experimentation service. So in order to do that, we can run this command. And I've noted here that we're passing in the name of the experimentation account name and then the resource group of Azure ML. And I had a feeling that some errors may happen. So let me try running that command again. Oh, it says that it already exists. So let me rename this to Demo 01. Sorry about that. And so what this is doing is going out and building the experimentation service for us instead of going through the user interface and all the different blades within inside of Azure. It may take a moment to create everything. So now we didn't get all the red, and it returned back the provisioning state of it being enabled. So it's starting to build out our experimentation service. So now that is being created, let's switch back over to the workbench, and we'll refresh our project and see if this comes available. Let me switch back over to Azure real quick and see if that is being built or has succeeded being created. Yep. All right. Now let's see if this refreshes. All right. Okay, I apologize for this. Let me sign out and sign back in real quick. So while we're waiting for that, one nice thing about the workbench is it is connected with Azure in the background. So all the commands that we're doing in the command line is really what's going on behind the scenes in the workbench. So it's just a nice user interface that sits on top of the command line. And so here it's saying that it's checking the experimentation account for the one that just got created. Okay. And here is the ML Demo 01. So the workbench did pick it up, and it did get created successfully. So now let's create a model management resource.
So when would I use the experimentation service?
We'll be using it here shortly. So it's used for whenever you have a model or some type of project that you're working on, it will contain your the project itself and your model and all the related information. So really, what's in here is your experimentation with inside the workbench.
Okay.
So now we'll create the model management resource. And this is where we'll deploy our model and images and the web service for our experimentation project.
What is the
That's been,
IDE, the Visual Studio Code?
yes, it's just a lightweight version of Visual Studio.
Okay.
Next, we want to set up our environment and compute options. I've got a URL here that we'll go and review real quick. So our local deployment is used to deploy and test our web service on our local machine, and we can set up our local environment using this next command. However, you need to have Docker installed on your local machine. The local environment also creates all these things for you inside of Azure. So we're not starting out locally developing. We do need to create resources in Azure first in order to get everything set up, and then we can bring those resources on our local to work with from there. So it'll create a new resource group, a new storage account, an Azure Container Registry, and an Application Insight account. We'll also look at spinning up a cluster that'll be a Azure Container Registry with Kubernetes as the orchestrator. And this is used for much larger scale production ready model development. So this is the command that will create our ML demo local in the Azure ML resource group. And it found a existing environment, but I don't want it to reuse the storage, so I'll just tell it no and use my current Visual Studio Premium subscription. And so that's provisioning, and it may take a little while to set up. So while we're waiting on that, we'll also set up the cluster. And in order to do that, you have this cluster flag, and I'll name it appropriately with cluster. And we'll create a new storage and ACR, and use that previous subscription or the current subscription. Okay. And so Azure Container Registry. So the to see the status of how this is being deployed, or the provisioning state of it, we can run this environment show command. And there it says that my cluster got 2 nodes in it. It's in the East US, and it's currently being created. So this may take 10 to 20 minutes to be built for provision. So we'll go ahead and continue on, and let me make sure that the local one is available or has fully been provisioned. And it says it's still creating.
So when you select to create a local environment, what is actually what is the deliverable or output of that process in Azure?
Okay, in Azure, we'll have a new resource group, a new storage account, Azure Container Registry, and an application insight account.
Okay.
So we'll have everything set up for us to store our models, the images, and manifest, and then we can download that locally and then work with that image locally to test it and troubleshoot things, and then be able to send it back up.
Okay.
Let's double check again and make sure that this is finished creating. All right, great. Says it succeeded. So now we need to, once that step is complete, we need to set our current context to our local environment. So we can do this with the environment set command. And then there it says that the compute has been set. So now we can get into building our actual model. And the one that I picked was the iris flower data set. This is available out on GitHub under the Machine Learning Samples Iris site. And we'll just take a quick look at it. And so in GitHub under Azure, there's a whole bunch of machine learning samples. And this is the one I selected for classifying an iris flower. It uses the iris flower data set, which is over here on Wikipedia. It's just a multivariate data set produced by Ronald Fisher back in 1936. And it's just a whole bunch of 50 samples from each of 3 species, Setosa, Virginica, and Varicolour, and then 4 features were measured. So we've got the length and width of the sepal and petal. And to show that, you've got a sepal and petal. So it's just different attributes that got measured with the flower. So now we can go through, run this command to see all available project samples available to us within the command line. However, it kind of has a lot of text to sift through. So one nice thing is in here, you can create a new project. And it's really, that command is looking at these different available samples to choose from. But they're all available on GitHub. So, I would recommend reviewing them there.
On GitHub, is it JSON format or?
No, it's pulling down all the information about it. So, well, I'm sorry. Yes, it is in a JSON format that gets returned. Yes, you're right. But it's just the links and descriptions and different URLs that get pulled back from within here. So here's like the GitHub link, an ID, a name, and then the summary.
And what's the question if the result returned in format, or where you're trying to verify what is actually included in each sample?
Well, so it's on, the data is on GitHub.
Oh,
and
yeah.
I was just asking what format, I guess, the data is structured in.
Okay.
In that.
So the GitHub repository actually includes not just the data; they include the full experiment with all the scripts and all of the models already pre-built to analyze the data. The actual format of the data that is posted on GitHub, you can expect it to be in a file-based format. I really have no idea what is used in this experiment. Say CSV or something of any probably most common.
Yeah. CSV.
But it is, you can treat that as a source control repository that is publicly accessible. So you have to do it in the browser and pick what file it has and what format there is.
Okay, so it's the whole project, I guess.
Right. Yep.
So,
yep. So the we'll go ahead and now that we've selected that sample, we'll go ahead and create a local copy of it. So this will go out and do a pull request from GitHub to download all the files. So we'll pass in the name of the project, the workspace, our account for the experimentation, our resource group, and a path to the local folder. And in this case, I put it in this Azure ML and then demo iris. So we can also see that if this will refresh, the demo iris project was also picked up inside of Workbench now. And to show those files, here's all the files. And then in VS Code, so here's those same files. So the different Python files, the CSV that we'll be using, and then here is so it's just a straight copy of the files down to our local, and then the Workbench picks it up, and Visual Studio Code is seeing that same folder.
May I ask a quick question?
Mm-hmm.
I like the fact that you showed in parallel what can be done with the UI in the Workbench and what can be done in the Studio Code.
Mm-hmm.
Does the Workbench actually include any built-in like terminal or CLI or something that would allow you to do everything inside of the Workbench?
Not necessarily. So in order to do that, they have a file, and you can open a command prompt or open up PowerShell. They currently, and you can configure it with either Visual Studio Code or PyCharm, but there's no current built-in support for any of the model management or experimentation or what was the third one?
Well, I think it's a model management. I'm not sure.
The experimentation service gets taken care of. The model management doesn't have any interfaces, but I'm sure they're going to build all that in soon. A lot of this is still in preview, so most of it has to be done via the command line.
Okay.
Oh, this in the Visual Studio command prompt, is that just basically a command prompt? Could you do run those same commands?
Yeah. Yeah,
Okay.
we could open up just a regular command prompt here
Okay.
and run the exact same command.
Oh,
But I'm just using Visual Studio Code because it has some additional features, being able to see the folder and interact with Docker and things like that. So now that we've got our project, we will change directory to it so that we can work with all those files. And now, so let's take a look at this experiment before we actually run it. So the data set is this iris CSV, and it has the different widths and lengths of the petal and sepal, and then the species that's associated with it for classification. The iris sklearn is the file that we're going to use in order to submit to run our project. And what this does is reads in that data, separates out the features and labels, generates 40 new random features to add to it, splits it into test and training so that we can build our model based on the test data set and then train it against a different data set. This then uses logistic regression in order to classify whether or not which species it is. So let's go ahead and
I guess let me ask a quick question. One of the steps that you just described appeared to be adding some random features.
Mhm.
What is the rationale for that? Is it just to make the data harder to classify, or just for the experimentation purposes?
Since there's only 150 records, they wanted to add more to it in order to help the model better train with. So the more data that you have and can use for training, then the better you have at scoring it properly, or for it to run with more examples.
I see. So basically, the label says that we're adding features as opposed to adding cases within the sample set. So I'm trying to understand whether we are emulating additional cases or additional observations, or whether we are adding extra columns with variables that we use.
Yeah, no, it is extra observation.
Okay.
So I think that may be should have been a different word there instead of features and observation.
Okay.
So if you if you weren't using a sample, you would have to build out this configuration file yourself.
Correct.
Like for other scenarios. Okay.
Correct. Yeah.
And this is all of the information that you would have to include in it, or is it just dependent on what you're trying to do?
Yeah, it would be dependent on what you're wanting to do.
Okay.
So we'll go ahead and run that locally. Got some links here to scikit-learn is what's being used, what's running, and it's a machine learning library built into Python. And it's using logistic regression to predict that iris species. So here we see that it's currently running, and there it goes. Okay, and now that that has completed, let's say we run this multiple times and we're tweaking it and want to see, well, what is the best model that got predicted. So here it gives us our accuracy, the regularization rate, when it was created, how long it took, and the ID. So now we've built a model, we've trained it with data, and we've got a 67.9% accuracy. That's decent. It's not 50%, but it's a little bit better than 50% accurate. So we'll just go ahead and use it for demo purposes. So what I need to do is get this run ID here and paste it in. And what this is doing is promoting our model so that we can download it for working with and building out our Docker image. Now let's download a copy of it. And then I'll copy it out to from that asset download folder. I'm copying it out to the root folder so that we can have this schema JSON file be created. And this is required for building out our manifest for the image. So this is creating the JSON schema file that we'll take a look at here in a second. So the schema service has been created and promoted, and now we'll download a copy of it locally and then copy it to our root folder. So now if we take a look at it, it shows us the input that's required and then the different properties that is expected for that service. So it's really creating the interface for our web service. Okay, and now for the machine learning model management. So this enables management and deployment of machine learning workflows and models. Docker images are used to provide flexibility for running in multiple environments. So to show this, so we've gone ahead and created our model, we've stored it, and we've created our schema JSON file. Now we're going to upload that into our machine learning model management. And we have to register our model and then create a manifest for our images using conda dependencies, which are packages and libraries that will be built into our image, and then any runtime files that are required. Then we'll send that over to our Docker image registry, and then we can deploy that to our local machine or IoT devices or a virtual machine, or we can have it run in Azure Container Services. So here we'll create a new model. Actually, let's go out. Since we have it created, let's go out and take a look at it. Oh, that's the experimentation. I'm sorry. Let me refresh this. and look at the model management. And under model management is where we will see the model, the images, manifest, and services that get built.
So for the model management service, is there any dependency on the underlying or on the experimentation service that was previously used to build the model, or can you complete your experimentation, blow up your experimentation resources, and just leave the model management resources?
Yes, you can do that. Once you have your model management set up, you could move it around or even have it in a different description. With this, you can, so long as you have your conda dependencies and your schema JSON and your model, you can ship that to any model management that you want.
Okay.
So within here, we'll create our model, and then the manifest, the image, and then the service. By default, it creates a model for us, which is based on the iris model. It also creates a manifest. So now let's create our own, and we'll just call it model 000. So that's taking our model file and uploading it to Azure. And there it went. Next, we want to create our manifest using our score iris and the service schema, as well as our conda dependencies and the new model ID that got created right here. So we will copy that, paste that in, and this is going out and creating that manifest. And once that completes, we'll switch back over to Azure to see that. There it goes. All right. And so now here's our new manifest of 000 and the model 000. So next we'll want to create the image. And the image gets created using, we'll name it image 000. It uses that score iris Python file. It also needs our service schema and conda dependencies, as well as our new manifest ID. And so while that's running, the next step that we're going to do is have it download the image that gets created, and we'll run it locally in Docker. And just to make sure, I do have Docker up and running.
In terms of the typical pattern on board, is image create is one after you have completed the development of the model and created an manifest for it, or is it best practice to create the image on a some type of periodic basis, or refresh your dependencies and that stuff?
Right. Yeah. You could definitely set it up to have it be created. You would have to use some type of orchestration to create these commands for you each time you create a new model, or you can do it yourself. Normally, what I see, in the community is people will build their model and then deploy it out and keep that kind of iterative approach. Using Docker for that is, you have these really small images all around, and you can have different versions of them. So you can keep them up and running, and as one of them increases, accuracy, you can leave it there or you want to try something else, add more features, or you have new data, you can spin up a new version of it and then work with that simultaneously, together. That way you can see how each model is performing and best tune each image.
Okay.
And it does take a little while for this image to get created. It's about 2 gigs in size, so it may take a moment here. But the next step is creating the web service. And what that will do is pull down the image to my local Docker and run it there. All right, there it went. And so the next command is this, and we'll send it in that new image ID. And while that's running, I'll switch back over to Azure, and we'll see that this new image is created. So it did get succeeded. It's a Docker image, and it's set for local environment. And then here is the ID associated with it.
I guess with the version is where you would apply some kind of version and then for labeling the evolution of those images.
Correct. Yeah. Each time you create a new model or manifest with the same name, it will version it for you itself. Yeah. And another nice thing is you can do creation of all these commands inside the user interface in Azure right now.
That's helpful as it lowers the barrier to playing around with that.
Mm-hmm. Yes. Okay, great. So now that downloaded, it stood up a new Docker image and container. And it looks like I have one from a previous. Let me remove that. And okay, so now it says that we can send in running this command either on the command line or in PowerShell, and we'll send it a new input of the different length and width of a brand new measurement. And so this should come back and predict for us which of the 3 flower species that it was. So there it says that it's Iris setosa. So that was a Azure ML service. What it's doing behind the scenes is sending a command to a Docker container that's running that model that we just built. Another thing that we can do is get all of our real-time usage, as well as so the URL that's currently running is here. We can go out and view the Swagger documentation for it, and it also gives us a command line interface to call it, or we could use curl. I'll just show that real quick, which is the same values, and it comes back as Iris setosa as well.
In terms of the output and get from the service, if you wanted to get some additional metadata about the confidence in the class or some other details from that, do you need to define that as part of the service, or is there a separate method that you can call within the repository there?
So there's a built-in model data collector that every time I'm sending a new input to it, it's collecting all that information and storing it in a storage account, a blob storage account that records the input and the predicted value, along with a whole bunch of other metrics that we can look at later
Okay.
and consume with Power BI in this demo.
Okay. That's really cool.
Yeah.
I think it actually answered a slightly different question than what I was asking.
Mm-hmm.
For the service or for the client that is calling it, how would the client know the degree of confidence in the single class that is returned?
That's true.
And if you,
Yeah, I'll have to follow up with you on that because
okay,
it only this only returns back the value that got predicted. Within your service schema, you can define different outputs, so you would have to set it up through there. But you would also need to change things within your that model script and the way the model gets built, along with possibly conda dependencies or sending. Depends on what you want to send back out. If it's just the accuracy, then it's probably just adding another output of that.
okay. I think that answers my question. That you find that beforehand based on what you do.
Mm-hmm. Yep.
Okay.
So, real quick with Docker, it's a packaging software, and the best definition that I found was on their website, of course. But so Docker allows you to have a kernel and then different containers that have your applications built into them. So a traditional virtual machine, you would have your infrastructure, then you would have hypervisor, Hyper-V or VMware, and then your VM would sit on top of that with a operating system itself, and then all your bins and libs plus your application. With Docker, it sits in your host OS and is just your application and your bin and lib inside of a container. So it's a much more a smaller footprint than your traditional VM. And we can take a look at, and it has its own command line interface. Here's the current images that I have. Here's the one that just got created 8 minutes ago, and you see it's 2.12 gigs. Most VMs, they're 20 gigs or more. And this shows the active container that's running. If we look at the image ID, and we'll do a Docker image inspect on that ID, we'll get back JSON specifying what is in the image itself. And as you see, it's Linux-based and running the MML Spark container. So for model management, we will switch over and look at this. Okay. So collecting the data is done automatically, and we can do that using going in and viewing the storage account associated with that service. We can also run this AZML environment show, and that will give us where our storage account is located. And it's always updated you may need to wait 10 minutes on the first web request. However, I went ahead and since was preparing for this, I created another Kaizen ML function, an Azure function that's been running for a couple days now. And what it's doing is it generates random values for each of the sepal length and width and petal length and width, and then posts that to another cluster that I've got set up. If we look at the monitoring of that, it's been running uh, 1,600 times, and I've got 5 of them running every minute. So we've collected quite a bit of data from that. So if we go out to our storage account for this other cluster that I've got set up, we can look at the storage account and so what it does is saves these files as a CSV in model data. And then under our subscription in Kaizen ML Demo, Model Management, the service, and then here's the model, and then our input. And it gets saved based on the current day. So here it is for the 8th and the 9th. So here we have a 4.14 megabyte file. So let's go ahead and download that as a input. And so one nice thing, well, before I do that, one nice thing is we can set all this up with Power BI. So here it is with a previous download of everything, showing that here's the time and the species that got predicted and the input values that were sent in. And we can see here's a listing of the number of predictions that have happened per species, and then the average measurements per each species as well, broken down. So if we, I'll just go ahead and download to show that how to update our report. Goes to data collector. And this was a input, so we'll save over that. And then we'll go back and download the prediction. For the 9th.
Battery.
Yeah, my battery's about to die. It should be just enough though.
Okay.
And we'll save that over the prediction. And then that's saved. We'll refresh this and we should see our numbers greatly increase from 285, 180, and 960.
Yeah, and that is profession. It's a data collector by default storing the data in Azure block storage, regardless of whether you're running the model locally or in Azure or would it store data locally.
If it's local, it doesn't record anything. So it's only when it's deployed to the cluster. So I've had another cluster set up and running for the last couple of days, collecting all of this data. So then the last thing I wanted to show was, well, we've got all of this set up, but how do I actually interact with it? So I went out and I've got a Azure web app that's running Python Flask located here. And to show you the code, it's under here. And it's running Flask with the WCF forms and allowing us to input the different links and widths, so we could have this like on a mobile app or something, and somebody could be out measuring the flower and seeing, what it is. And then we send all of that data to our cluster in JSON format, and then it will return back what was predicted. And so here's my application where I can enter in those different values. So let's say we say 8, 1, and 1, and that'll predict. And so this is going out and hitting the service that is a part of the Azure Container Registry, or hosted on the Azure Container Registry. So that one came back and said it was Iris Setosa. So let's change this to 2 and 2 and 8 and 8, and possibly get Iris virginica. And if we say that this is 1, 1, 2, 2, and 2, then that should be Veriscolor. So this is sending our input information to the Azure Container Registry that has the service and the model that we built out. Mm-hmm. And then all that data gets collected in the model data collector that we can then look at in Power BI and see how our model is performing. And then, we can either use this data and send it back for more training, because now we're growing our training set, or, use it for tweaking and doing other things to our model if necessary.
So in terms of expanding your training set, what workflow would be used to accomplish that? From the data that gets captured through the login of the usage of the model, what typical workflow would be used to actually convert that to train this data for your model?
Gotcha. So you would take the CSV that gets downloaded from the storage account and then apply that back into, into our base CSV, and then build it up from there.
Okay. So it seems like since the output of this, or I guess we can say that the data captured in our data collector output is really just the unstored raw data with export produced by the learning model will be subject to the biases and inaccuracies that the model itself has.
Correct.
So we cannot make the model much smarter by training on its own predictions. It would just reinforce the inaccuracies biases that it has.
Mm-hmm.
So
right.
Looks like our approach might be to get the data that has been captured, identify records where probability of accurate prediction for a threshold, mm-hmm. and then for humans or someone to go and manually proper manner, rescore the value that's been captured, and then apply that as influence of the thing.
Correct.
Okay.
Yep. Yeah, definitely having, in this case, having a human go in and review that probability or the accuracy of that would be very beneficial.
That's really cool.
Yeah. That's all I had.
And the examples that people shown, or I'm sorry, the samples that are available on GitHub that would be followed here appear to include some applications of machine learning in ways that are more complex and sophisticated in the sense that your inputs do not have to be just screens and their numerical values to get their input set up and those purposes that can accept audio files that inputs that you can make sense of them as well.
Correct.
So,
Yeah.
so I think it's helpful to understand that the same tools, the platform to take the next step, building out more complex models of complex data types.
Mm-hmm. Absolutely.
That is a great talk and a great demonstration of this. I think you have covered quite a lot of ground, and fun to see the entire process from start to work with results. Thank you so much, Lucas, for doing that.
Thanks.
Hey Lucas, can you provide the Python file that you were using?
Yes, absolutely.
Thank you.
You're welcome.
Yeah, and appreciate the presentation.
Yeah.
Yep.
You're welcome.
Thank you.
Yep.
All right. Any other questions that we can take before wrapping up?
Real quick, I'm just curious. You had mentioned some possible opportunities at LGE for machine learning. I was curious what maybe a real world.
So one thing that we're looking at is equipment failure. So trying to predict when something may fail, given all their data that they have for historical failures, work order analysis, as well as weather data.
Yeah, that's also sensor readings as well.
Yeah,
right?
We could also look at that from generation and see their how their power plants are functioning and different sensors that they have reading different pieces of equipment. Be able to detect abnormalities or prevent failures or a whole number of cases that they have.
I was curious, like in a real world scenario,
Right.
How?
Yeah, it's not all modeling flowers, seeing which species it is. I mean,
obviously that would be much more complex, but
right. All right. Well, if there's nothing else, I will go ahead and stop the recording.
Nope. Thank you very much.
Yep.